Okay, in this video I'm going to talk about using Lewis symbols to predict the structures of ionic compounds. So we're going to go through a small example here using KCl and show that Lewis theory is able to predict the correct chemical formulas for a lot of basic ionic compounds. So the first thing we have to do is look at the electron configurations of our elements, which I have written here. And we want to think about what are the valence electrons, because those are going to be the ones that participate in the bonding. So let's look at our electron configuration here and identify the valence electrons, which for KCl are the 4s1 level, and for Cl they are in this 3 level. So these so in this in the potassium, there's 1 valence electron, and in the chlorine, there's 7, which we know already. So let's now draw their Lewis structures. So we know that to draw a Lewis structure, we take the element from the periodic table and then represent the valence electrons as dots. So the Lewis structure for the potassium is given by the symbol K, and simply 1 dot. And the Lewis structure for the chlorine is given as Cl with 7 dots. So we'll do 1, 2, 3, 4, 5, 6, 7. So we know already that this compound is KCl because it's very simple. So what we know is that the potassium is going to lose an electron, and it's going to become K plus 1, and that it's going to be transferred to the chlorine. So the way to represent this in a Lewis structure is the following notation. So I'll just make it very formal. I'll draw the plus here, and what we're going to end up with is K plus, as we know already, and then Cl is going to have 1, 2, 3, 4, 5, 6, 7, and then represent it with this. It's going to have the extra electron that came from the potassium. And the way people typically represent this is by drawing brackets around the anion and putting the minus symbol. So now we can look at our electron configurations. K plus has an octet from the previous energy level, which is here. So now K has a full outer shell. Cl also has a full outer shell because we are giving it this extra electron. So the Lewis theory is able to predict that this chemical formula is KCl, as we know. So let's do another example, actually. So let's do something a little more complicated. So now we're going to look at sodium and sulfur. So we have our electron configurations written here. Once again, we're going to look for the valence electrons. So for sodium, of course, it's in this 3s level. And for sulfur, we have also the 3 level, but there's 6. So here there's 1 valence electron, and here we have, 6. So we proceed as last time. We're going to draw our Lewis structures here. So for sodium, it's the same as potassium, basically. We have the symbol plus a dot. For sulfur, we have S with 1, 2, 3, 4, 5, 6 electrons this time. So you might be able to notice just by looking at this is going to be a little different from last time. Basically, it's the same idea. This time, sulfur is going to need 2 electrons to complete the octet, which means it has to combine in a ratio of 2 sodiums for every 1 sulfur. So let's draw that. So here we have our sodium with its plus charge. Here we have our sulfur with 1, 2, 3, 4, 5, 6 electrons. I'm going to try to draw them in red. So here are the electrons from the sodium, the 2 different sodiums, and as I've said, there has to be 2 of them. So we're going to pop a 2 out in front, and then we are going to put our brackets in charge. So now sodium is going to lose its 1 electron to have a full octet, and the sulfur is going to gain 2. So we're going to predict that this chemical formula is Na2S, just as it's found in nature. So basically all of this is to show that Lewis theory is capable of predicting the correct chemical formulas for ionic compounds.